So we'd just like to welcome everybody to the second Sasensei International Dojo, SID2. We have Charu Shankar, who's going to be confessing to us about the SQL procedure.
Thanks, Alan. Thanks, Sasensei. I don't really see myself as a sensei, but it's an honor to be able to share whatever I've learned through my different years at SAS about SQL. Now, SQL can take years for us to understand every single element of it. What I'm going to be doing, and I'd like to do a screen share if this is possible to share my slide deck. If someone can give me permission.
You should be able to share.
I have a disabled participant screen sharing here.
Okay,
Message.
1 second, I'll change that.
Thank you.
Yep, you're good to go.
Super. So you all can see my screen, and these are my confessions. I have quite a few of them, not too many, I hope. So here's a little background on me. I teach at SAS Institute, and I'm a blogger, a yoga teacher, and chef, in addition to my love for SAS. My 4 confessions are going to be these 4. Some of you may already know some of them, and some of you just may be a little bit more addition to your expert knowledge already. So let's begin with my first confession. If I look at an overview of SQL, and pretty much everybody here in this room probably uses SQL. 2 things SQL always needs is what do you want and where do you want it from. The what is on the select, what columns do you need? And the where do you want it from is in the from clause. So these 2 are mandatory. But SQL needs many more statements from you if you want to ask more questions of it. Here is the entire syntax order. Now, much like most of you, I speak a few computer languages, a few human languages, and it's hard to keep language syntax and grammar in order. So here's my mnemonic. So few workers go home on time. This is how I keep it straight, and I know that the language of SQL respects this syntax order now. This is very different from the logical query processing order. If I have time, I'll go into that. This is the way SQL expects me to make requests. However, it's not the way SQL is going to process my work. My second confession has to do with dictionary tables. Many of you have heard about these likely. It's a way for you to explore your metadata. And they are read-only metadata views. They are created when you initialize your SAS session. They are updated automatically by SAS, and you have read-only access. The best beauty of dictionary tables is it's a rich source of your session metadata. So you can pretty much gather information about what libraries do I have, what tables do I have, what 10, etc. Typically, when I start or work with dictionary tables, I have no idea what's in this table. So I'll run a describe table statement to get a sense of the columns in this dictionary table. And then it'll come back and say you have a column like CR date, which is creation date. And once I get this information through the describe statement, I can go and start to access these tables. Here is a dictionary table called dictionary columns. I have 3 columns there that I would like to get: name, type, and length. And I want to limit my search. And I really, whenever I use dictionary tables, I want to ensure that I restrict my search by adding the where clause and adding in a filter. So here, I want to limit my search to the SAS help library, and I want to grab the member or a member name that is cars, so the cars data set. So I'll get this, and most of you are probably likely not impressed, and you'll say, yeah, I can get this with proc contents, big deal. So I can go one step further and say, I need to do some joins, and I like to look at common columns. So I run a SQL query where I explicitly ask for the SAS help library, and where the name, and I upcase it. I'm not sure whether the IDs are stored in lowercase or uppercase. So I run an upcase function on name, and I ask for the contains operator. And that'll give for me all columns which have an ID as part of it. Once again, not super impressive because you had to explicitly type the word ID. What if you could ask the metadata, ask the dictionary tables to give you a list of all common columns dynamically without you hard coding the words, the letters ID? So here's my confession. Here's how I do it. I will ask for the columns I need, name, type, length, the name of the table, which is member name. I want this from dictionary.columns. I want to limit my search to the SATSELF library. I want to group the columns by name. And then here's the magic component, having count of name greater than 1. So give me all the columns that repeat more than once. And voila, you're going to get all the columns and the tables they exist in. The column called actual is appearing in 3 tables, and the column called amount is appearing in a whole bunch of tables. Joins are going to be so much easier now because you don't have to go running either proc contents, or you don't have to ask dictionary tables specifically. You let SAS do the heavy lifting. You can extend this to much, much more. You can even, know that data is one of the biggest principles of data workers. You can even go and ask the dictionary tables to give you a listing of all columns which have same name but of different type, so that later on when you're starting your join, you don't run into this little hurdle of, oh my goodness, the types are different, I need to do something. That was my second confession. My third confession is one of my most favorite things of SQL. It's to summarize data. I know I can summarize data in many languages, but SQL just is the best, in my opinion, especially with using the Boolean. So let's understand the Boolean a little bit. What we know about it is the entire digital computing world operates on the Boolean. Everything is a yes or a no. Everything is a 1 or a 0. In fact, in real life, everything basically boils down to the same thing. We ask the question as we head out of the room, is it going to rain? Yes. Okay, take an umbrella. Is it going to snow? Where I'm in Canada, it snows quite a bit. It may even snow in May sometimes. Is it going to snow? Yes. Then wear your boots, etc. So we are going to learn how we use this basic fundamental computing principle to gather information, make a request to SQL, and summarize data, something that no other language, in my opinion, can do with so much elegance. So let's take a look at this confession. Here's my business scenario. I'd like to see a count of the total numbers of managers and the total numbers of employees. So basically, a report that shows me the haves and the have-nots. On the same row, I want to see number of managers, number of non-managers, and the manager-employee ratio. Now, if I was to consider using a where clause, the where clause could give me either the managers or the employees, possibly not both on the same line. How do we get this report? Some of you may already have experimented with this. Kudos to you. And those of you who haven't, I'm going to first go break it down step by step and figure out, is somebody a manager? How do I know this? I look at the job title column. The word manager should appear there. If it does, yes, manager. If it doesn't, for example, the second row is a secretary, that person is not a manager. Very simple. Now, how do we now turn this into the zeros and ones that we need into the Boolean? We are going to use a find function. And the find function needs a few arguments from us. It says, give me what you're looking for, the column, which is job title. Secondly, give me what string you're looking for in that column. Here it's manager. And then you have some optional arguments. Here I've added I, which is ignore case. My data is not clean. I'm not sure it's uppercase, lowercase. So what the find function will do, it'll go scanning every row of data. And for each row of data, the minute it finds the word that you've provided as your second argument, it'll return you the column position of the first occurrence of that word. Here, it's 16. Now, 16 is not a 1 nor a 0. How do we convert it? We'll do a trick here. We'll go ahead and add on the select clause, find, and the whole expression, and then we'll say greater than 0. And what does that do? The question then is asked by SQL, 16 is the column position I got. Is it greater than 0? The answer is a resounding yes. So that becomes a 1. If somebody is a non-manager, then the find function will give me a 0. Is 0 greater than 0? No. So that returns you a false. So that's how we'll get a series of zeros and ones by converting the find function into the Boolean, like so. Any manager will have a value 1. Any non-manager will have a value 0. Now it's just a matter of wrapping this entire expression with a sum function to be able to add up all the managers. Likewise, the sum function for the non-managers will give the find expression equating to a 0. After that's a piece of cake. I just divided calculated managers by calculated employees, knowing that SQL asks me to use a calculated keyword. This is Proc Sql, by the way. And the calculated keyword will ensure that it's going to use a column that has been built on my select clause. It is not an existing column. Awesome, job well done. We use the Boolean and we managed to do it so much efficiency, so much elegance that it might take a few rounds in some other languages, computer languages, to get to this result. My last technique is where American National Standards Institute falls short and Proc Sql steps in. So ANSI, short for American National Standards Institute, is the worldwide standard for SQL. And most SQL vendors like Oracle or SAS or DB2 are expected to add their own isms into it. Like SAS will have a few isms. Now there is somewhere where SQL falls short. Let's take a look and see how SAS can jump into the rescue. Here's where we tried to make a view portable. So Tom Zhu is a sales manager. Tom needs access to personal information just for his staff. Data he needs is in 3 different data sets. You got the addresses table, you have payroll, and you have organization. Some of the things we need to remember about Tom is he shouldn't be allowed access to data for any employees that is not part of his direct reporting structure. Secondly, Tom can write very basic SQL queries, but he's really not familiar with complex SQL queries and joins. So what we are going to do is build a view for Tom so that he can access it just as if it was a data set, as if it was a table. So this is the part about a view. It's a stored query. It has no actual data. And the nice thing about a view is it's going to extract the underlying data each time it's used. So it's very dynamic. It's going to get the most up-to-date data. The code for the view is very simple. Up above, before the select, I add the create view statement. And in the view itself, in the select itself, this is essentially a SQL query. It's just a join. We're joining the 3 tables. On the where clause, you're providing the join condition and also adding a filter for the ID for Tom Zhu, which is 120-102, which is 1 rows pertaining to him. The view is defined. And the view looks like this. In the same library, it's stored, and it looks like a data set. You know, the icon of a data set is a table with a red ball on the bottom right. And the view has a set of gears indicating work in progress, meaning only when I run the view will it extract the data from these 3 data sets. So SQL in Proc Sql says the default library for the view, for the tables, excuse me, the addresses table, the payroll table, the organization table is the same location as the view. So it's called co-located tables, which means I can skip putting in on the from clause the library references. And for a lot of SAS users, you might come and think about this as, does that mean these are in the work library? No. In relation to the view, these are co-located. These indicate that the data sets are in the same location, right? And this is actually an ANSI requirement that the tables and the view need to be co-located. Now Tom does what we all do. Tom has been given the view by you. He then copies this to a folder on his hard drive, and he says the view doesn't work anymore. He asks for your help. So Tom submitted this. He went ahead and treated the view as if it was a data set. He knows a simple order by clause. He runs it, and he gets these red messages in the log that the data doesn't exist. And the SAS system, you know how it is with errors. It doesn't like the fact that you didn't respect the language rules. It comes to a complete stop. So what does Tom do? What did he do? He violated, very big word here, he violated the one-level naming convention in the from clause. And he didn't do it on purpose, accidentally, by moving the view to a different location, suddenly that location doesn't have the tables. There is no more co-location. So this doesn't work. So I'd like to introduce to you a way in which Proc Sql has an edge by adding the using clause. By adding the using clause, I'm now able to give Tom whatever he needs, and then he can take this view and he can lift it and save it wherever he wants. This using clause specifies the library for the location of the data sets of the table that I'm using in this view, right? And if you see here, you'll probably say, oh, by the way, the phsug library is being used for the view as well as for the tables. Which phsug is this using clause alluding to? It's basically alluding to this location of the data sets. Tom can definitely create another phsug library and save his stored view. Perhaps he saved it on the C drive. He can go and save it there. No problem, it won't conflict. So there it is, the visual of having the ability to store the views separately from the location of the data. That brings me to an end of the session. Here are some links you might find handy. At the bottom is my best programming tip for 2012. I was so blown away by the Boolean expression in SQL that I made my number one tip for 2012, and there's a lot more here. I thank you all for your time, for taking your valuable time out of a Friday to listen in. Here are some ways you can reach out to me. And if there's any questions, we can open it up now.
Just want to give one comment, Bart here. This first part when you were saying that the order of SQL keywords is totally different than the order of executing the program under the hood. That was exactly the stuff I was talking to my student this Wednesday. So exactly the same thing I was doing with my students this Wednesday. And this last thought you were sharing about this using clause. A few years ago, we've been with my colleagues, we've been preparing a database for our colleagues from sales department, and basically thing was that the original database was good structured relational database, right? So normalized and so on. But the guys from the sales department, they as exactly as you described the user, this Tom here, they weren't very good in querying. They wanted to have everything in the one big white table with everything inside. So we just create them a bunch of views. We put them in separate location. We use this using clause to redirect the original data, and they were happy with the views, and basically exactly using this approach, right? So yeah, these thoughts are I think very useful, and you could spread the word all around the world with them to show them to the people.
Excellent. Thank you for sharing, Bartek. It's really useful to hear that these are actually already used. And if those of you are curious about the logical query processing order, I do have on my blogs, I do have a beautiful visual drawn by, I think the name of the individual is Dick Ben-Gan, very cool name. But also my SAS Global Forum hands-on workshop is actually going to talk about that. And as we speak, I believe the SAS folks are putting up those videos of everyone's hands-on workshop. So I hope you get a chance to listen in on that one. Any other questions, comments?
I do have a question about the dictionary tables.
Yeah, please go ahead.
So, as I understand it, when you assign a library, all the metadata for all those tables will be added to the dictionary tables automatically. If you've got a lot of pre-assigned libraries, then your dictionary tables are really large. If you're like on a BI server, which is a ton of pre-assigned libraries.
Right.
Does that suggest that maybe it's a good idea for people to actually try to unassign libraries where they can, to keep the size of those dictionary tables more manageable?
Oh yeah, hi Quentin. So I think you have actually raised a couple of possible ideas that are coming up with my mind. It may not be the answer you're searching for, but you've triggered off some more thought processes. And if you don't mind, I'm happy to share that. I think it's a good idea not multiple libraries if you're not using them, and assign libraries as and when you need them. And when you finish deassigning, and then that's point number one, and I'm sure the senseis in this group will be able to chime in when I'm finished here. There's one more thing I want you to be aware. Actually, there's 3 comments. The first one is the assigning of libraries. The second one is absolutely introducing the where clause every time you access a dictionary table. Because otherwise, SAS is going to explore every single dictionary table, and it can actually freeze and use up your computing resources in a way that you don't wish. Thirdly, dictionary tables get the maximum punch when you use Proc Sql dictionary.columns. A lot of people would go ahead and use, for example, proc print and use a SAS help library directly to access the dictionary tables. And I would suggest that is not a better way to go about it. Again, in my SAS Global Forum paper, I have compared the time differences in the two. When you use a SAS help library directly and you don't go via Proc Sql, you don't have the ability to optimize your where clause. In the proc print or any other procedure, SAS starts up a discovery process, basically opening up every single table, examining the metadata before it gets you what you need. So those are 3 things that got triggered off by your question. I'm not sure if it answered your question directly, and if it didn't, then maybe somebody else can chime in.
No, those are very helpful thoughts. Thank you.
You're welcome. Any other questions? Any other comments? I'd love to hear from you.
Just one more thing, if I may, because you've been using these Boolean expressions, and one thing which I was using for calculating multiple different data aggregated in different ways was just to putting case when clause into summary function, and it works really well also. And especially for users who are not very familiar with the Boolean expressions, right? Because like less experienced, this case when clause inside the summary function will give them like more feel what is happening under the hood, right? So
Yeah.
that was one thing which I was using with my colleagues who were like less experienced. So you basically could put into summary function the case when clause with multiple conditions.
Yes, excellent. And I think the Boolean can sometimes be a little bit confusing. So there is a blog that I wrote that I hope you can see my screen. Are you able to see my website? Yes. So in the Boolean, you don't have to use a find expression. The only reason I use a find there was, and it's not that you said it, Bartek, but I'm just sharing because again, you triggered off a thought. The find function was used because my data needed to be explored. I needed to strip out the manager portion. But I can certainly make my expression as complex as I need, ands or nots, and all of that will transform to a yes or a no. And especially for those of you who work in health, we did some analysis, and this is a 2013 Global Forum paper of mine with Andy Kuligovsky. Some of you may be familiar. So this is people who had diabetes and who did not have diabetes. That's my grouping. And the columns themselves, each of them is deriving a Boolean by adding an expression. Sum up those individuals, and the data was Pima Indians in Arizona, highest level of diabetes in the world, but they had 0 count at one point, and we were trying to explore why. So we were comparing them with the Mexican Pima. So body mass index is less than this age group, this glucose count. another body mass index, another age group, another glucose count. So you see how you can take the Boolean and basically make it do whatever you wish it to do. That expression can be as complex or as simple as you need. So just a little bit of addition to what you said, Bartek.
I'm so happy that I see your web browser, and I'm so happy that I'm not the only one who has the same look with 100,000 open web pages.
Yeah, I keep getting a lot of flack from my colleagues, and they'll say, "Don't you realize you're using up so much resources? And then if you complain that things are slow, but I need to have multiple things open. I'm constantly looking up things." Just like you, just like most of us.
Exactly.
I have a question.
Yes.
Why do people quit? Or a better question, why quit?
Why quit? Yeah, so Proc Sql supports what's called run group processing. And that means, so if you take the example of me, the instructor here, for example, who's also a student, by the way. So I enter the class and I enter the Zoom room, and you go on asking me question after question. You can throw as many questions as you wish. Maybe I'll answer them. Maybe I'll answer all of them. Maybe I'll deflect them back to you and ask you to respond. Regardless, you have the ability to go on asking me questions. Once I leave the room, then you have to call me back. That's a bit of an expense, isn't it? So the quit says, you've left the room completely, and I have to invoke SQL again so that I can ask SQL all the questions again. The advantage of the quit, I can have another select before the quit. So a second question, a third question, a fourth question. So there's a minute efficiency gain by not asking SQL to leave memory, but to stay in memory as long as I keep throwing questions.
You know, that's a good question. I was once asked by a client, what kind of performance gain are we talking about? They wanted to know, should they go back and actually optimize all their deployed code, where they would make sure that the Proc Sql all the selects within one bracket, or shall we leave it as it is? I couldn't justify to them the expense going back and optimizing it, because the gain didn't look that big. From your personal experience, constantly coming out of Proc Sql and going back in, what are we talking about in terms of CPU cycles and performance gain? Do you know?
Benchmarking would be the way to go, depending on your customer's data. It's going to be very customer specific, right? I just think it's minimal, but if we are learning best practices, why not learn them from the ground up and employ them going forward is my thought process. Doesn't mean that you have to go back and reinvent. And I'll add to that another thought. If your customers are working in Enterprise Guide automatically puts a quit, and then you have to invoke SQL again. So if you're working in windowing environment, then there is a minimum of performance improvement, I would say. And as somebody who works in data, as a data worker, anytime I can get efficiency, I learn a new technique, I'm bound to start using it again. So that would be my short answer.
I personally, I never quit, but the one reason I do know for doing so is options S timer. You get the run group timings.
Exactly. And that'll be a good way for your customers to figure out options full S timer and then compare CPU time. But then, was it Vasile who asked the question?
Yeah.
I'm going to say with benchmarking, that could be another topic, maybe another user can share. Benchmarking means that we need to run that program at least for a minimum of 5 runs. And we need to open the code, open the SAS session, test it out, close the SAS session, and then open another SAS session to try without the quit. Because you know what SAS does, right? If you've seen car racing, the lead car is, I think it's called drafting, the technique, but the lead car creates this little vacuum behind it. And then the second car gets pulled along easily without a lot of effort. So in the same SAS session, if I have 2 procedures, the same procedure repeating itself, then SAS is going to load modules in memory, and the second run is going to be a little bit faster. So the recommendation for benchmarking is enter SAS, test it out, leave, enter SAS again, try the next technique, with the options full list timer turned on, and then you can get a better sense.
Charu, thank you very much. We're about to get cut off due to the 40-minute
Zoom. Oh yes, of course, it's 40 minutes, thanks.
Yep. But I just wanted to say thank you very much, and from everyone in the room. and for everyone who turned up.
Thanks so much, all. Take care.
Thank you very much. It was super
Charu.
cool.
Thank
Have a
you.
great
Bye.
afternoon.
Take care. Bye.
Bye-bye.
Bye.
Bye, everyone.